Welcome everybody, my name's Scott Hebbard from Sparx Systems, and today I look forward to presenting on the key to smarter business decisions, introducing DMN with Enterprise Architect. I'd like to begin by defining DMN and outlining how it can help you to make smarter business decisions. DMN, or Decision Model and Notation, is an OMG standard that provides a comprehensive framework for modeling and executing decisions using visual diagrams, decision tables, and business rules. DMN helps organizations improve the decision-making process. It allows you to enhance transparency and achieve better business outcomes. On screen, we have an example of a decision model in Enterprise Architect. The business knowledge model outlines the inputs and business knowledge that may influence or impact the business decision. This approach allows an organization to capture and represent their business knowledge in a structured manner that is easy to read and easy to explain to stakeholders. In this webinar, we'll examine a business knowledge model, or BKM for short. Enterprise Architect offers dedicated expression and simulation windows for defining decision logic using decision tables, literal expressions, boxed context, and invocation. We'll use a number of Model Wizard examples to demonstrate what each of these types are and how they work. This should help get you started to create your own DMN projects. Finally, we'll learn how to run and evaluate a DMN simulation. Learn how to easily input and edit decision rules, perform simulations, and evaluate decision outcomes to gain valuable insights. Decision types. There are 4 distinct types of value expressions. The following table will outline each of them, and we'll step through some examples to highlight how each of the 4 work. Decision tables. Enterprise Architect provides a comprehensive decision table editor to define decision rules, conditions, and actions in a tabular format. This visual representation simplifies the understanding and maintenance of complex decision logic. Literal. Enterprise Architect provides a user-friendly editor for creating and managing literal expressions within DMN models. Invocation. DMN allows decisions to be invoked from other decisions, promoting modularity and reusability. Enterprise Architect provides seamless support for invoking decisions within DMN models, enabling users to build modular decision models and enhance the overall efficiency of the decision-making process. Boxed context. With boxed context, users can define decision-making boundaries and encapsulate decision logic within a specific context. This helps in organizing and structuring complex decision models, making them more manageable and easier to maintain. I've used the Model Wizard to create a decision using each of the 4 different types. The examples should help illustrate the differences and make them clearer. The first example is a boxed context, which provides a collection of context entries consisting of name and value pairs, each with the result. They are often clearly defined by their if-then structure. If we have a look at the DMN expression window, you can see the if-then structure displayed as part of the installment calculation. There are a number of inputs, including the product type, rate, term, and the amount. We can run the simulation and we can get a result. We can now make changes to any of these inputs, but we're going to change from a standard loan to a special loan. If we save the changes and run the simulation again, we can see that it's gone from 2,553 and 43 cents to 2,558 and 43 cents. So moving from a standard to a special loan has increased the monthly repayments. The next thing I want to look at is a decision table. You can see with the columns, you can identify whether they are an existing customer, their application risk score, and the result will be the risk category, whether we should give this customer a loan. So it could be very low, low, high, or we could decline altogether. The input values are false, so they're not an existing customer, but their score is 133. When we run the simulation, we can see that row 8 has been highlighted, which means they are very low risk. So we could happily give them finance. The next example looks at how to invoke other decisions. An invocation calls on another model element. In order to calculate the difference of two squares, you need to invoke addition, subtraction, and multiplication. Each of these decisions are clearly defined as shown on screen. When we look at the difference of two squares, we then evoke addition, subtraction, and multiplication. We have two input values, 5 and 3. So 25 take 9 is going to be 16. If we run the simulation, the result is clearly displayed on screen. The final example is a literal expression that describes how output is derived from its input variables. It's a simple payment which uses a rate, a term, and a principal in order to calculate a monthly repayment. We can make changes to any of these input variables, save those changes, and run the simulation so we can compare results. This time we're going to use a principal of 30,000 as shown in the example and run the simulation, producing a result of 143.22 cents as the monthly repayment. In order to showcase how to make smarter business decisions, we're going to look at a few worked examples in Enterprise Architect. These include examine how a decision table works. We're going to calculate the area, surface, and volume of a sphere. We're going to look at a card example with a list of suits and ranks. We're going to generate code from a DMN model. And we're going to look at DMN model validation. When we're examining the decision table, we're going to have a look at the different types of hit policies. So for example, U stands for unique, which means only one of the rows or associated rules can be true at the one time. You can see there are other hit policies, including any, priority, and whatever comes first. We're going to look at a number of worked examples, and some of the examples are shown on screen, such as the card example, the cylinder example, and looking at some of the basic elements of a decision model, and stepping through a simulation process to see how it all comes together. Enterprise Architect also supports code generation. This code can then be exported and used in production systems. You can insert breakpoints and step through your code so that you can understand every single step in the decision process. Enterprise Architect also supports simulation. So on the left-hand side, you can see you have risk data. So the individual is age 35 and they have not defaulted previously. They have monthly expenses of 3,000 and a monthly income of 12,000. So with this input data, based on the rule sets, this finance application is accepted. The simulation results are published in red on screen and give people a nice, clear, simple and easy to read way of running a simulation and making a decision based on that data. On the right hand side you have a typical decision table with a number of different rules, and you can see along the columns you have your risk assessment, affordability, application decision, and for each of these options Enterprise Architect supports auto completion so that it eliminates errors. Enterprise Architect also supports validation, so the button that we're going to select is the one with the green tick, and what that does is it then runs validation on your decision table and all the results are displayed in the system output window. So in this webinar, we're going to discuss some of the benefits of using DMN in Enterprise Architect, including understanding the overall decision process. We can help businesses make better decisions. We can run simulations from models to predict outcomes. We can experiment with different input data sets. We can validate your decision models to help identify logical errors early, saving time and money. Let's do a deep dive into a decision table example. A decision table is a tabular representation of a set of related input and output expressions organized into rules indicating which output entry applies to a specific set of input entries. From the Perspectives menu, select Requirements followed by Decision Modeling. This will bring up the DMN Toolbox, DMN Simulation and DMN Expression windows. Everything you need to build, model and simulate your business decisions via DMN. The model wizard contains a large number of examples with detailed description of how each is made, and even includes links to the relevant user guide and help information where required. Gives you everything you need to get started. The difference from the previous example is that this one has a DMN simulation configuration element, which we can then use to generate code and step through our simulation. If we zoom in on our decision table, we can see a unique hit counter with 3 distinct rules. It's important to note that the square bracket means that that number is inclusive. That is, it's included in the rule. So if the input is greater than 8, you'll get a result A. If the input is between 5 and 8, you'll get result B. And finally, any number less than 5 produces result C. Once again, the square bracket means that if the input is 5, the result will produce result B. Before we run the simulation, let's generate some code. We can open and view the script in Enterprise Architect Script Editor. This allows us to insert a breakpoint and to step through the simulation to better understand results. When we run the simulation, based on our input of 8, we can see that the result is result B. The cylinder example helps to demonstrate a reusable decision service, which is used to calculate area. Then calculations for both surface and volume reuse this service. Some simple mathematical calculations are used to calculate the area using pi and the radius squared. Looking at the diagram on screen, the inputs to this decision include the radius and height. Given a radius and height of 10, the expected result for the surface area is 1,256. The results are shown on screen. When we run the simulation, the volume and surface area are displayed in red, while the circles that represent side 1 and 2 are obviously identical circles. Now that we've seen the expected result and explained what we're hoping to achieve, let's run through the entire simulation. Once again, the Model Wizard provides a comprehensive explanation of the process so you can try it yourself at home. The main point is that we can reuse the decision service that calculates the area of a circle. We can generate the model and examine the decision model in more detail. You'll see under DMN Expression that the radius of the circle is defined and the cylinder and all the various sides, side 1, side 2 and side 3. Side 1 and 2 are circles, side 3 is obviously the vertical side for the cylinder. There are calculations to determine the surface area, which is simply adding the area of all 3 sides, and the volume. Now let's run our simulation and look at the expected results. Looking at the results in more detail, up the top you can see that both surface and volume have been displayed. Surface requires all 3 sides, and volume also does. What I'm going to do now is I'm going to generate out a script so we can look at the code that's been generated in order to calculate the area and the surface and the volume of our cylinder. At any point, we can right-click and insert a breakpoint, and this will allow us to step through our simulation and go one line at a time to see how things are calculated. We can now run our simulation, and you can see that execution is halted at our breakpoint. We can step over each line of code and see as results are created. So in order to create the cylinder, it creates the area for slide 3, then slide 2, then slide 1, and you can see that both slide 2 and slide 1 use the circle area calculation decision service. I find stepping through a simulation is an extremely powerful way to understand how decisions are made and to identify any issues or ways that you might be able to optimize your systems to improve results. This code can be taken and used and deployed in other systems if you find that decision valuable. This example uses a card deck to showcase how Enterprise Architect managed lists in making business decisions. A list decision type is a single list of items containing values. In our example, we have one that is called rank, while the other is called suit. Rank contains a series of strings such as ace, 1, 2, 3, up to 9, 10, jack, queen, and king, while our suits are defined as club, diamond, heart, and spade. We also have a literal expression decision called rank times suit. Using these, it calculates the ranking for each card type in a game. It uses a for loop in a rank times suit to iterate through both lists. In this case, the for loop is defined as a field statement in the literal expression. For R in rank, S in suit returns S plus R. Once again, we've used the model wizard to establish our DMN model. When we run the simulation, we get a combined list that adds each rank and suit. After a decision model is created and simulated, you can generate a DMN module in Java, JavaScript, C++, or C#. The DMN module can then be used in Enterprise Architect's BP Sim execution engine, or an executable state machine, or your own project. Enterprise Architect is capable of validating your decision model. This helps you to identify logical errors early and make smarter business decisions. The parameters, arguments, and logic of DMN expressions are implemented largely by text. To make modeling easier and more reliable, Enterprise Architect provides validation. Validation identifies modeling errors caused by typos, logic, incompleteness, inconsistency, and so on. In this first example, we have a decision table with 4 rows. Select the button to run validation on the decision table. Results of the validation appear in the output window. This example is not complete because if the input, for example, is number 3, it is not covered by any rule. The same can be said for an input of 7 or 12. Enterprise Architect clearly identifies the completeness validation error and outlines the suggested fix. In this next example, we have a consistency violation because rules 1 and 2 overlap. For example, if the input is number 5, it would meet criteria for both rule 1 and rule 2, and under a unique hit policy, this is simply not consistent with the rule design. Once again, the results are outputted in the system output window. It is important to note that while these examples are simple and straightforward, complex rules with hundreds of rows may be much more difficult to identify using just the eye. So simple rule validation in Enterprise Architect has a lot to offer to improve decision making. Let's look at another example. In this example, we're looking at a parsing error. Clearly, input 200 is a typo. Someone's made a mistake. When we validate, it identifies that it cannot be parsed. If we go in and make changes to input 200 and replace it with input 2 and rectify the typo, we can rerun the validation and see how the results change. Now when I validate the results, there are no errors and no warnings. The movie list example allows us to use two invocation decisions for inputs into a film selection decision. This example uses the Australian standard for film classification, but could be easily adapted for an international audience, allowing us to select all movies that are PG or parental guidance from a given genre, such as fantasy or action. While our movie list is quite small, you can see how this example could be scaled or altered to suit another topical business search. If we run our simulation, we can do a search for all mature movies from a genre such as fantasy. In order to do this, we need to set the input for my search. This raises an important topic of autocomplete. One of the advantages of using autocomplete in Enterprise Architect is that it prevents typos and errors during your search. This time, instead of using M for mature, we're going to select PG from our list of options and run the simulation to search for all parental guidance movies from the fantasy genre. This time, once we save our results and we run our simulation, we're going to get two results, Harry Potter and Beauty and the Beast. In this webinar, we examined the key to smarter business decisions using DMN. Enterprise Architect simulation capabilities empower users to run simulations directly from DMN models. This functionality allows businesses to predict and analyze a decision, improve business performance, and achieve desired outcomes. The webinar examined 4 decision types, including literal, boxed context, invocation, and decision tables. We were able to break down complex ideas into a network of interrelated decisions, rules, datasets, and knowledge sources. We covered everything from the surface of a cylinder to the search for a suitable movie title, and much, much more. At the conclusion of this webinar, it is hoped that you can use Model Wizard examples to simulate a decision, generate code, and work with a simple decision table. Conduct what-if analysis. I'd like to thank you for your time and look forward to seeing you at our next webinar.